Hi there. If you saw my previous video, then probably by now you're wondering why there is this RAM stick laying here on my desk. We should be video card, we should be fixing video cards now. Great question. Let me do some explaining. Yesterday I was about to do a video on video card repair, no pun intended, and yeah, my test rig just threw 55 on me, as can be seen in the next dramatization. Well, as it turns out, 55 is not a lucky number. How do I know that? Well, 55 is a postcode for no memory detected. That's in a case of AMI bias, which this motherboard has. So what it basically means is that motherboard can read an SPD from this memory stick, but it cannot see any other RAM chips. So it's bad, really bad. Like if it was 53, then it meant that there is no memory installed at all. But 55? Yeah, it's pretty much says one of those RAM chips is gone. So what I would probably do most of the time by now is just go online and buy a new one. This is DDR3, 2 gigs of it. It shouldn't be expensive, like $10 or so. But since I have all of this video and audio set up now, well, I should probably fix it. Let me check my junk box and get back to you all. So this is what I came up with. This is SO DIMM stick, same DDR3, same 2 gigs, but as you can see they are not very compatible. But no, what the f? This is DIMM, this is SO DIMM, this is for desktop, this is for laptops, but it still kinda looks promising. And what I mean by saying it looks promising is that both of those sticks has the same basic memory architecture. And what I mean by that is that there is 16 memory chips on this stick and same 16 on this stick. 16 times 2 gigs, same architecture.
Say
architecture.
again, I dare you, I double dare you.
So, at least in theory, we should be able to take one of those chips and put on this board. But before doing that, it might be a good idea to check the part numbers under microscope. So let me get rid of those labels and well, we'll go from there. Yeah, that Kingston label, well, it was a dog to get rid of. It was a fighter. It stood up for its rights to be there. Yeah, whatever. Okay, so now we are under microscope, and as can be seen, we have Elpida chips here. Elpida, I don't know how to pronounce that, but what I do know is that is kind of big producer of memory chips. So we shouldn't had any troubles to find a datasheet for those. So it's a J1108BFSA, and on this SODIMM we have LPITA2 G1108BFBG. So there's a slight difference, 8BFSA and 8BFBG. Yeah, so what it means is that I don't know what it means. Well, let's pull those datasheets and see. Okay, so we are at the datasheets. As you can see, I was able to find both of them for BFBG and BFSA. And yeah, after first glance, I can't see any differences on the first page. That's a good news. Now that I have the datasheets, like 147 pages, lots of reading, but we're not interested in that. What we are interested is the markings. So let's find that. How convenient, the second page. Okay, so what does BFBG really means? It's power supply, that's okay. F is die revision and BG is package. And here, same power supply interface, different die revision, package, FPGA. 78 ball FPGA, 78 ball FPGA. So it looks like it's the same package. Let's look at the pinouts. Yeah, they're the same. Let's see if there's a package drawing. So this is the package drawings, and I can't see any differences whatsoever. So I think we're all good. Now that we found out that all of those chips are basically the same, I could just start removing the good ones, reballing them, soldering them back to this stick, and that would make a very long and, I would argue, not very interesting video. What I would prefer to do now is to find out which exactly one of those banks or two of those banks are bad and change them. That way I don't have to do a lot of repetitive work and you have yourselves more interesting video. So, how do we find out which of those RAM banks is bad? Well, one of the techniques that I often use is to use my thermally calibrated and certified finger. And by using this technique, I was able to establish that this particular RAM bank is getting very hot. So, it has to go. But how we will know that this solves our problem? Well, if this chip is getting hot, then I think it's pretty much safe to assume that it has a short on power supply. So I think it would be a good idea to measure the power supply resistance on this whole bank and then measure that resistance afterwards, after we remove that particular suspected bad RAM bank. That way we will know if it solves our problem or not. Now you might wonder, where's the power supply on this particular DDR3 UDIMM board? And that's a very good question, which I don't know answer to. I mean, again, we have to Google, have to find some data sheets and figure it out. Yeah, of course, I mean, we can just measure on the caps. Probably all those caps are power supply decoupling, but some of them might be not. Some of them might be some reference voltages and whatnot. So let's play safe and, find the schematics. Okay, and we are back to our screen capture. I was able to Google out schematics of motherboard by Gigabyte, model GAF2A55MS1, if that means anything to anyone. And by the way, hi to everyone at Gigabyte. I promise we will not copy anything. So let's look what pins do we have at this DDR3 slot. Yes, so first two are VTT. which my guess would be terminating voltage. Yeah, VTT termination voltage. VSS, which is obviously the ground, and VDD, which would be 1.5 volts. I don't know why they're marking as 15 volts. That doesn't make any sense whatsoever. And we have VDD SPD, which would be 3.3 volts to the SPD EEPROM chip, if I'm not mistaken. We don't care about that. What we care here is a resistance between one of those VSS pins and one of those VDD pins. As you can see, they're all tied up together, so it would be enough to just measure resistance, let's say between pins number 2 and pins number 51. So let's get back to our table and do just that. Okay, we're back at our bench and let's find out which pins are which. So this dimstick has 240 pins, that's 120 pins at each side. And let's say that this is pin number 1. So this would be pin number 48. Believe me, I counted them. And this would be pin number 49, 50, 51, and so on. So how do we check if this is really pin number 1? Well, let's look at our datasheet. I'm looking right at it, and ground was pin number 2, number 5, and number 8. So we should have a continuity between those pins. Let's check it out. Let's turn our multimeter into continuity mode and let's check. So pin 1, 2, and 3, 4, and 5. Yep. 6, 7, and 8. Yep. Well, actually, I don't know, maybe you can see that on camera. With my own eyes I can barely see that, but I think that both of those pins are going to the ground plane. Yeah, so that's 100% ground. Okay, what next? Next, let's see which pins are our power supply. Our power supply was pins number 51 and 54. So if that's 48, 49, 50, 51. Yeah, I can see a beefy trace coming out of it, so that's again a dead giveaway that this would be the power supply pins. Let's see what resistance do we have now between the ground and power supply pin. That's pin number 2 and 51. Oh my, that's a dead short. 2.2 ohms. Okay, so it seems we have a short on a power supply. So let's remove our suspect and see if that solves our problem. So that was my first time doing a BGA on camera, that is, and that went surprisingly well. But I bet my bottom dollar you will have your laugh when I will be putting those chips back. Okay, let's see now if we have made any changes to our short situation here. So let's put our multimeter into the resistance mode and check our resistance between pins 2 and 52, which is power supply. Yeah, short is gone. And what we actually can see going on there on multimeter is basically we're charging the caps, the decoupling ones, and something is discharging them back. Like maybe a chip is starting up and discharges the cap and the multimeter charges it up. So I think this is a normal behavior. We can cross-check that with our good SID. Yep, that's exactly the same behavior that we saw previously. So I think all is good. Now let's take this one working bank from this SID and let's try to reball it and put on a non-working board. So our chip had its dance and now it's cooled off. But what I really want you to pay your attention to is the amount of residue flux around it. Like, it's not much, it's barely noticeable. I mean, if it wasn't under the microscope, you wouldn't be able to see any of it. And that's why I really like those non-clean fluxes. I mean, those real ones, not the Chinese ones. That stuff is not cheap. Actually, it's really expensive. But you know what? I think it's worth every penny you pay for it. So now I'll clean this board and we will see if we fixed something or maybe made it even worse. Okay, we're back at our bench, and I did check that we have no shorts on our power supply pins of camera, and we don't. That is good. That means that we didn't make it worse than it was before. So now basically what's left is see, will it ram or will it not? So I promise I do this for the first time. I didn't turn it on before because basically I want to be able to catch that magic smoke if it comes out of there. That means a lot of views always. So, okay, I mean, let's do this. And we have code 15, I think 55 was before that. And I think we're all good. Yeah, B7 means it's booting. All right. And I have memtest running now for an hour or so. And as you can see, everything seems to check out. So I guess that wraps it up for this video. Thanks for watching and see you next time.